Good morning. You and me are going to be talking about the area of circles today, which is chapter 10, lesson 3 for pre-algebra. Now, circles are cool, but they've got some stuff going on for them, which is the radius and the circumference. And we're going to use that, and the idea that if you were to take a circle and fold it in half and then a half and then a half 4 times, you're going to end up with 16 little thingies, right? And then if you cut them out, just like this picture shows, you're going to get basically 16 triangles. And then those triangles are going to have rounded edges, right? But then if you kind of put them together, down facing next to an up facing, down, up, like shown here in this little figure right there, you're going to get something that looks a lot like a parallelogram. And we're going to use this idea that this parallelogram is going to help us figure out the area of a circle. So, the area of a parallelogram is base times height. So here, the base is the right there. And so if you look at it, the base is actually half of the circumference. So if you were to look at the circumference as like the edge of those triangles right here, like that's an edge of a triangle, edge of a triangle, edge of a triangle. So all of them added up together gives you the length here plus the length here. But if we're just looking at the base of the parallelogram, it's actually half the circumference. All right? And then the height of my parallelogram is actually the radius. Right? So the radius is there in red. All right, so then if we're using the area of a parallelogram as the base times the height, that's 1/2 the circumference times the radius. Now, if you remember from the last chapter, circumference is pi r squared. So the half of that cancels out, so the half and the 2 cancel out, just leaving me pi and 2 r's, which would be r squared. So that gives us the actual area of a circle being pi r squared. Pi r squared. All right, so we're going to use that a lot today. All right, so now if we're going to find, that's going way too fast. If we were going to find the exact area of a circle, we would use pi. And a lot of you are going to be like, well, pi is 3.14. Well, the thing is when we're finding the exact area, we're not going to actually replace pi with 3.14 because 3.14 is an approximation. It is not exactly what pi is. And actually, it's impossible to work with pi exactly because the number actually never ends. We would never actually be able to multiply pi as its true number by anything because we would never stop being able to fill in the number pi into our calculator. So that's why we use pi as an approximation if we're looking for an approximate answer. But when they want us an exact answer, we actually just use the symbol pi and just say, hey, it's that number, pi. You know that one goes on forever? Well, since we can't actually calculate it and we're looking for the exact number, we just leave pi as it is and just say whatever is happening to pi times pi, and that's going to be the area. So, if we're going to find the exact area of a circle with a diameter of 12, we need to start with pi. The area for pi, right? And now we know that the diameter is 12 because it tells us diameter is 12. But we actually need the radius. Well, radius is half of a diameter. So if we take the diameter and divide by 2, we're going to get the radius, which is 6. And, diameter divided by 2. Okay, so we're going to place r with 6, and then we're going to square it. So 6 squared is 36, and that just gives us 36 pi. So when they're asking for the exact answer, you leave pi as pi, and you don't multiply by 3.14. Okay, so the exact area of a circle with a diameter of 12 is 36 pi. Now, it's not a very simple answer, but it's the exact answer, and you need to get used to knowing that when you're dealing with really crazy numbers like pi, to get an exact answer, you just leave pi as pi, but if they want an approximate answer, you change pi to 3.14, which is what we're going to do in this next problem. So, for real-world situations, you usually want an approximate value for the area of a circle. If you're finding an approximate area, you use 3.14 for pi. So the size of a mountain lion's territory depends on how much food is available. Where there's plenty of food, the circular territory, I think that's supposed to be circular territory of a mountain lion lion, not lane, lion, and that's supposed to be circular. Line may be as small as 5 miles in diameter. Find the area of such a region to the nearest square mile. So here we're looking for an approximate answer. So putting pi into your answer is not a good idea because you're going to get it wrong. Instead, we're going to replace pi with 3.14. So if we take the area, oh, and we're also going to use the approximate wavy lines. So if we take the area of a circle, which is pi r squared, we're going to square the radius. Well, they told us that the diameter is 5. So we're going to divide 5 by 2 to get the radius. So that's 2.5. And again, we're going to use pi as 3.14. So I'm going to replace pi with 3.14, and I'm going to replace r with 2.5. Now I'm going to do some math. Now remember, we do PEMDAS here, so we're going to do the exponent multiplication first, so 2.5 squared, which is 2.5 times 2.5, and then we're going to multiply that by 3.14, which is the approximate value for pi, and that's going to give us an area that is approximately 19.625 miles. But since they wanted it to the nearest square mile, we are going to round 19.6 up to 20 miles squared. So there you go. That's the approximate region, territory, or area of a mountain lion who has a diameter of 5 miles as their territory. All right. So finding areas of irregular figures. What we can do is when we have a crazy shape that is not quite rectangular or not quite circular or not quite triangular or trapezoidal or any of those other things, is we can break irregular figures into shapes that you can recognize and can determine the area of. If an area is missing, subtract the two areas. If an area is attached, add the two areas. So here we have a rectangle with a half circle taken out of it, which means we're going to subtract because that half circle is missing from the rectangle. So we're going to first find the area of the rectangle, which is base times height, which is 10 times 5, and then we're going to find the area of the half circle. All right? Well, it is half a circle. If it was a whole circle, it would look like this. All right? Pretty much as a whole circle as I can make it look like doing this freehand. So we find the area of the circle and then we multiply it by a half. So this is the area of the whole circle, but multiplying it by a half will give me just this region. Okay? Well, we know the radius is 2.5 because it tells us right here. And so r gets replaced with 2.5, and since we're finding an approximate region, they don't ask us for the exact region, we're going to replace pi with 3.14. So 1/2 times 2.5 squared, 2.5 times 3.14 times 6.25, because 2.5 squared is 6.25, multiply that by 3.14, then multiply by half, and the area of that half circle is 9.8125, approximately. Now, since I'm removing that area of the half, I'm going to take my rectangle and subtract my half circle, which gives me that. So that means that the rectangle minus the half circle it has an area of 40.1875 centimeters squared. And that's it. Oh, now here's an example actually of an attached region where you're going to find the area of a rectangle. Oh, let's get rid of all that. If you find the area of the rectangle and then we're going to add a half circle, that's the attachment. So it's a rectangle plus a little extra, whereas the other problem was a rectangle minus a little area. Okay, so just make sure you're keeping track of that and you know what you're doing. All right, bye guys.